Okay, so 5.6, this will be our last section for this week. Most likely we're going to split it into 2 days. We'll see how today goes, but I think that's what we'll probably end up doing. Yeah.
Wait, do we have a test?
If we split this into 2 days, then no, I don't think we would. So probably what's going to happen. Okay, we'll see how it goes, but I don't want to rush to it. Okay, so inequalities. Just a quick reminder again. What does that symbol mean?
Greater than.
Greater than. How about that one?
Less than or equal to.
Less than or equal to. Good. That one?
Less than.
Less than. And that one?
Greater than or equal to.
Greater than or equal to. Yep, perfect. All right, so the first thing on your guided notes, it says a linear inequality in 2 variables, and then I'll show you the part you need to write down. So basically, all that you do when you have a linear inequality, the difference between an equation and an inequality is this, that thing I just circled. Okay? What is that called? That's an equal sign. If you take the equal sign and you replace it with one of those 4 symbols, then you have an inequality. So that's what you want to write down. So a linear inequality in 2 variables results from taking an equation like this and then write down and replacing the equal sign with one of those 4 symbols. Okay, so you're not going to see this symbol today when we start doing examples. It's going to be replaced with one of those 4. Now, when we solved systems of equations, does anyone remember how many answers did we have to find?
2.
2. We had to find what were usually the 2 letters. They don't have to be these letters, but they usually were which 2 letters?
X and Y.
X and Y. That's exactly the same thing we have to do here. And when we find a solution, right, we're looking for an X and a Y. So like if let's say I picked this. I just made up 2, 5. And I wanted to know if that number is a solution to, let me make up something. X plus 3y is greater than 4. How would I check if that is a solution to that?
You would put in the numbers.
Yeah, I would plug in. What number would I plug in for X?
2. And
2. And what number would you plug in for Y?
You'd put 5 multiplied by 3 would be 15.
So you'd have 2 plus 3 times 5 is greater than 15. Well, what's 3 times 5?
15.
15. What's 15 plus 2?
17.
Okay. Is 17 greater than 15?
Yes.
Yeah. 17 is greater than 15. So that means this number is a solution. Okay, it works. Now, when we solved equations, that would be it. That'd be the only solution. Let's check this one. Let's check 4 and then 3. What's X now?
4.
4. And what's Y?
3.
3. I don't know why I made that 15. All right. Let's try it here. What's 3 times 3?
9.
9 plus X plus 4. What's 9 plus 4?
13.
13. Is 13 bigger than 4?
Yes.
Yeah. So this is another solution. This was a solution. Okay, so when we're solving an inequality, there's lots of solutions. Okay, not just one, okay, but there's lots of them. So a solution of an inequality, and we're going to put this on the next line. just the part that's underlined. So a solution of an inequality in two variables is any ordered pair that when you plug it back in, you get a true statement. Okay, so you're just writing down the part between and right here. A solution of an inequality in two variables. We usually use x and y. And then you guys already have the is part. Any ordered pair that when you plug it back into the inequality, you get a true statement. So you just have to write down the part that's underlined. All right, let's try one more. Can somebody pick a coordinate for me?
4 or 5.
4 or 5. Okay. And let's do 2x plus y is less than 1. Let's plug that in and see if it works. What's x in this coordinate?
4.
4. What's y?
5.
5. So let's plug in 4. What's 2 times 4? 8. And what did we say y was?
5.
5. What's 8 plus 5?
14.
13.
No.
Yeah, 13. 13 is less than 1. All right, what do you think about that? It's not true. That means this is not a solution. It doesn't mean there isn't another ordered pair that maybe is a solution. It just means this one isn't. Right? So that's how you check if something is a solution. Plug it back in and see if you get something that's true. 13 being smaller than 1 is not true. That's not true. Let's try this. So same thing we just did, except this is a real example 1. So all the notes are on the front for this one, and then all the examples are on the back. So we're gonna just flip to the back, and in the upper left box where it says example 1, we'll put it right in that box. Okay, so tell whether the ordered pair is a solution. So you guys have to write down this. So this is the thing that you're going to plug into, and then this is what you're going to plug in. This semicolon, it's just there to separate the two things. It doesn't mean anything. All right, so let's try it. What's x in this case? 10. So take 10, fill it in for x. What's y?
3.
3. So take the 3, and we're going to fill that in for y. Oops. So we actually want to fill that in. So we have 10 minus 3 times y, which is 3. And we're going to check if that's less than or equal to what number? 6. All right, let's see. What's negative 3 times 3? Yep, perfect. Negative 9. And what's 10 minus 9? 1. Okay, so is 1 less than or equal to 6?
Yes.
Yes, definitely. So what does that mean about this coordinate then?
It's true. And it's a solution.
It means it is a solution. Doesn't mean it's the only one, but it just means it is 1. Okay, there might be other numbers we could make up that would work too. Okay, so the answer here is yes, this is a solution. That's what you write down. Any question on that? Checking if a number is a solution. You just plug it in. Yes?
I did this before.
Oh, you did it before?
Yes.
Oh, that's good. Yeah. Excellent. Okay, any other questions on that? Okay, so what we are going to do now is we're going to graph these inequalities. The way you would graph this is very similar to how you'd graph something if this was an equal sign. We almost have to do exactly the same thing. So let me write that down. X minus 3y is less than. So this was less than or equal to. Let me just make it an equal to. If you wanted to graph that, does anybody remember what format it has to be in?
Some format.
Right. It has to be in y equals mx plus b. Is that y equals mx plus b?
No.
No. What's the first thing you would put on the other side?
X.
Yep. And how do you move positive x?
Minus it.
Yep. Minus it. These are gone. What's on the right-hand side? And just make sure we put this in the right order.
Six.
Negative x plus 6. Yep. Okay. Is that y equals mx plus b?
No.
No. What is still next to the y that we don't want?
Negative 3.
Yeah. Negative 3. How do you get rid of that negative 3?
The y both sides are negative 3.
Exactly. We're going to do these same steps, except we're going to do it when this is an inequality and not an equal sign. But it's the same thing. Okay? I'm not going to keep going, but that's the idea. All right, so we're going to graph these linear inequalities, but one thing that we're going to have to do that we didn't before is we have to shade. Okay? We're going to shade either above the line or below the line. So like, say here's your x's. You have a line like this. What we're going to have to do is draw this line, okay, by getting it in y equals mx plus b, and then we're either going to shade above it or we're going to shade below it. And I'm going to show you how you figure out which way you shade. So the only extra thing is shade. Okay? Everything else is exactly the way we've drawn lines before. Okay, so once you draw our line, you have to shade on a certain side of the line. Okay, so I think I have a chart that's going to break down kind of how this is going to work. Let me show you a picture on the calculator first. Let me put in an inequality. Let's do 3x plus 2. What's my y-intercept in that equation?
2.
2. And what's my slope?
3 over 1.
3 over 1. Yep. And what I'm going to do is I'm going to show you what it would look like if you shaded, I'm going to shade below. Okay, and I'm going to hit graph. Okay, so that's, we still have the line, just like we're used to.
Where are all those lines?
But all those lines are the shading. Okay, I shaded under it. Now,
I've done this before.
anywhere that you see shading, you could pick a coordinate in the shaded section, and it would be an answer to this problem. Can somebody name a coordinate that looks like it's in the shaded section?
0, 0.
1
Absolutely.
and negative 4.
0, 0. So whatever this problem is, 0, 0 is a solution. What's another one?
1, negative 4.
Yeah. So 1 looks like it's about right there. So 1, negative 1, negative 2, negative 3, negative 4. Perfect.
Does it go infinite all
Yeah.
the way to the right side?
Yeah,
So
it
you
just-
do like,
just
you could
keeps
do
going.
Like 100 billion and then 1.
Yeah, because that would be like
So basically,
Like
any
that.
positive and any number greater than thing.
well, there are some negatives that work. Like if you did, negative 1, negative 3, that would work too. All right, but it is mostly like to the right. But there are a few to the left. All right, so when I write down this, where did I just see it? Any coordinate that is in the shaded region as a solution, that's what I mean. How many coordinates are in this shaded region?
Millions.
Be more than that.
Millions.
Infinite, yeah. So that's why when we talk about inequalities, there are an infinite amount of answers. That's why when we want to draw it, we just do the shading, and that represents all of them. Okay. But I got to explain to you how you do the shading. Okay, so steps for graphing a linear inequality. What format do you think it has to be in first? Because the first thing we have to do is graph a line. Exactly. So make sure that your equation is in y equals mx plus b. Okay, so on your guided notes, put that down for step 1. Now remember, you're not really going to see an equal sign. You're either going to see a greater than or a less than, greater than or equal to, less than or equal to. But you got to get the y by itself on one side, and then get the mx plus b on the other. And then whatever symbol is in the middle, well, that's the symbol that we have. Okay. The next thing we do, once we get it in y equals mx plus b, graph your slope, just like we always do, and then graph your y-intercept. I might put those in the reverse order. That way you remember to do b first and then m. Always do y-intercept first, then you use your slope second. Okay, just a reminder about what b is. B is the y-intercept. Okay, so if you don't remember what that is, I would write that down. B is the y-intercept. That's the number that you start at on the y-axis. So if your y-intercept is positive, which way do you go to get to a positive number?
Right.
But on the y-axis.
Oh,
Up. And what if the y-intercept is negative?
down.
Go down.
Yep, you're going to go down. So that's B. And what does M stand for again?
Slope.
Yep, that's your slope. And just a reminder of what slope is. You want to think of slope as a fraction. This is a kind of all review. Slope is rise over run. And the two directions that we normally go are up and to the right or down and to the right. You would go up and to the right if you had a positive over a positive. You would go down and to the right if you had a negative over a positive. The only time I ever go left is if I'm running out of space. Okay, if I'm on the edge of my graph and I can't go to the right. Then I'll go backwards. But other than that, I always go up and to the right or down and to the right. And that's what this is summarizing right here. Now, what if your slope doesn't have a fraction? You need to make it one. What number can you always put in the bottom?
1.
Yep, you can always put a 1 if there isn't a number there. Perfect. All right. Now, once you plot your points, you'll have to plot your slope, then you'll plot your y-intercept, then you'll use your slope, then you're going to have enough dots that you can make your line. Now, there's two kinds of lines that we can draw. Does anybody think they know what I'm getting at? There's like two different ways we can connect these dots. We can either use this type of line, or we can use a different kind of line.
Like an up and down. Positive, negative.
Not positive or negative. I'll give you a hint. That's one kind of line.
Like that other way
With
around.
a bendy line, like.
No, it is going to be straight. It's not going to curve. The other one would be a line that looks like this. So the difference is it a solid line or a dotted line? Okay, that's the two kinds of lines. And it makes a difference which one you use. Okay, so on your chart, we're going to write down the 4 inequality symbols. And then we're going to look at what kind of line do we use and where do we shape. I think the special cases off to the side on your guided notes, I think we're going to do that tomorrow. I don't know if we're going to do the special cases today. Oh, never mind. We might. We'll see. Okay, so write down your 4 inequality symbols. And now let's look at the different kind of boundary lines. Does anybody notice a pattern for when you use a solid versus a dotted line?
When it's equal to, you use a non-dotted line, but when it's not equal to, you use a dotted line.
Yep, exactly. When you have the equal to underneath, you always use a solid line. Less than or equal to, greater than or equal to. Solid. When you don't have the equal to in the original problem, you use a dotted line. So you just have to look at the original problem. Okay, so if I just look at this one real quick, is this going to be a solid line or a dotted line?
Dotted.
Yeah, that's a dot. Would that one be solid or dotted?
Solid.
That one would be solid. Would that one be solid or dotted?
Solid.
That would be solid. Yep. So to tell if it's solid or dotted, that's pretty easy. All right, and now the shading. Well, when you draw a line, with the exception of a vertical line, you have a above and you have a below. When you think of the word less than, these first two, do you connect the word less than with something being below? Or when you see less than, do you think that means above? Yeah, less than. Like if something's less than something, it's smaller, it's below. So whenever we have a less than symbol, we're going to shade under the line. That's what I did on the graphing calculator. That's an example of shading under the line. Shading up here, that would be above the line.
I'm assuming the next two are going to be above.
Yep. So whenever you have a greater than in the original problem, greater than means to shade above. Only time this doesn't work is if you have a vertical line. With a vertical line, you don't have an above and a below. You have more of a left and a right. Okay, that's a special case. We'll talk about that after. Okay, does everybody should have everything on the front of your guided notes now, except for the special case?
Which is this vertical line.
Yeah, it's going to be the vertical line and the horizontal. And I'm going to do those, I think I have them on the next page. Yeah, right here. We'll do them after. Okay, does everybody have that? All right, so let's see if we can do it. All right, it says to graph y is less than 1/2 x plus 3. Okay, so on the back of your guided notes, flip it over. Example 2 is in the upper right. Okay, is this already in the right format, or do I need to fix it?
It's not right format.
Yeah, you're just looking for the y by itself,
It's basically,
the mx, and the plus b.
just don't think of the inequality symbol as just think of the inequality as equal.
Yeah, just think of it as like an equal sign, exactly. Okay, let's graph it. What's my y-intercept? 3. So where do I put the dot?
3 up.
3 up. What's my slope?
You go 1 up and then 2 to the right.
Yeah, my slope is 1/2. So I'm going to go 1 up and 2 to the right. Can I do it again?
Yeah.
Yeah, sure. You can do it as many times as I want. If you want to go 1 down and 2 to the left to go back the other way, you can do that. That's enough. Okay, so I got my line. Now, before we draw the line, we have to think if it should be a solid or a dotted. Look at that symbol. I don't care if I'm shading above or below. I'm not there yet. Does less than mean solid or dotted?
Dotted.
Yes, it means dotted. So I'm going to make my line. I got to fix it to make it dotted. I can do that. All right, so I'm going to make it dotted. Okay, so now it's dotted. Put it through my points. All right, so I got the line right. Now I have to figure out if I should shade above or below.
You would shade above.
Why would you shade above?
Oh, sorry, no. Since it's less than, it would be below.
Yes. Since it's a less than, you would shade below. So what I do is with my highlighter, I just
That was pretty.
kind of go like that. You know, it doesn't have to be perfect. You know, just on the test, the shading is very simple. When you click in a section, it'll automatically shade the whole thing. You just have to click once.
Wait, so how do I know which section to shade?
If it's a less than, you always shade below.
Oh, okay.
Look back at the table. Yep. And yeah, it goes on forever.
Even if it's a less than and equal to?
Yeah, like it just keeps going down.
Oh.
Like it doesn't actually stop right there. You know, it keeps going this way, down over here, and down this way, and it's everything under there. Everything underneath. Okay, so could somebody name a coordinate that's anywhere in the green?
Zero,
The
zero.
origin.
Yeah, 0, 0. So that means the point 0, 0 should be a solution to that. Well, let's see. If you plug in 0, 0, what's y?
0.
0. And what's x?
0.
0. What's half of 0?
0.
0. That's gone. Is 0 less than 3?
Yes.
Yeah, of course. 0 is definitely less
You
than
also
3.
do 1, 1.
Yep, you could do 1, 1. You could pick any point that's in the green. If you pick a point that's not in the green, then it wouldn't work. So the green represents all the solutions to this problem. And the reason that this boundary line is dotted is because if you pick a point right on the line, it doesn't work. Dotted means you can't be on the line. Solid means you can be. Okay, so dotted means you can go like,
Because
right.
it would be equal to.
Yeah, yep. So dotted means you can go right up to the line, but not up. Look at this one. All right. So first step, is it in the right format?
No.
Yes.
What are we looking for on the left by itself?
Y.
Y, and what are we looking for on the right?
So, mx plus b.
We're looking for mx plus b.
So it is.
Yep. There's a y, mx plus b. Perfect. Okay. What's my y-intercept?
1.
Yep. Y-intercept is 1. And what's my slope?
-2.
And we got to make that a fraction this time. So what do we put in the bottom?
Just put 1.
We'll just put it over 1. So from that dot, which way do I go to get to another point?
1. Sorry, no. Oh, for the y-intercept or the slope?
So from the y-intercept, I go.
Oh, 2 up and 1 to the left.
What? It's 2 down.
So let's go the way we normally do. We can go backwards if we want after.
Oh,
But let's do it the normal way
2
first.
down and 1 to the right.
2 down, 1 to the
Is
right.
it the same thing though?
It is, yes.
Yeah,
You can go up and left if you want to go backwards after. But as long as all your dots look like they're in a straight line. That looks good.
I've always done
Okay.
it.
Now, look at that symbol. Less than or equal to. What are my 2 types of lines I can use?
Dotted and
Straight and solid. No, dotted is straight and solid.
Dotted and solid. Which one is this?
Solid.
Yeah. What tells you that it's solid?
It's a straight line. What happened?
What tells you that it's solid?
The equal to sign.
The equal to sign. Yep, exactly. That tells you that it's solid. All right, let me put that in. It's not perfect, but it's okay. I'll fix it. Just put that. Good enough. Okay, now below is on this side, above is on that side. Which way do we shade this time, above or below?
Hello.
Yeah, this is a less than or equal to, so you're shading everything that's under the line. Okay, and that's over here. Okay, remember, understand it goes on forever. Okay, but I usually just shade it in like this. That's good enough. Okay, so that's everything below. Now, this time, we know that anything in the green is an answer. But how about a point right on the line?
It's fine. 'Cause it's not solid.
That's fine this time, yep. When it's solid, you can go right on the line. When it's dotted, you can't. Perfect. Okay, so any question on that? Yes. So I think there's only one left, and that's the special case. Okay, so I'm going to give you the notes on the special case. What kind of lines did I say were special cases?
Zero.
straight up and down.
Yeah, and what other kind of lines?
Side to side.
Yeah, so those are the two special cases. So if you have a problem and you only have a single letter, just a Y, or just an X, okay, that is a special case. Okay, a special case only has one variable. When you have one variable, the boundary line is either perfectly horizontal or perfectly vertical. It's not on a slant.
Do we need to write that?
Yep, so this is on the front side of your notes. This is that box. It's on the very bottom right.
No, the thing above it, do we need to write that? The one variable.
Oh, well, no, as long as you remember that one variable is a special case.
Got you.
Okay. If you have a Y with no X, does anybody remember what kind of line that is? Which special case?
Side to side.
Yeah, that's the one that goes left and right. That's horizontal, right? Goes across. Now, you got a little bit of room, not much room after, but I'm going to put shade. I'm just going to add that right here. So with the shading on a horizontal line, it's actually just like the shading I already showed you. Less than or equal to is below. Greater than or equal to would be
Above.
above. Yep. All right, now, what if you have an X with no Y? What's going to be the direction of your line when it's just an X?
Up and down.
Up and down. That's going to be vertical. Yep, up and down.
Today's class went fast.
Now, when your line goes up and down, you don't have an above and a below. Right? You have a to the left and a to the right. That's
Meaning
the two things.
it would be
But the
No
left side is the
solution.
negative side. So
So yeah, if you have less than,
it's less than, you're going to shade the left side.
yes.
this would be no solution, right?
You basically, with a vertical line, you just go with the direction that it points. If it points to the left, this would be a problem where you would shade to the left of the line. What if it pointed this way? Greater than or equal to.
Is that right?
That would shade to the right.
So basically, since the right up is always going to the positive, Positive number goes to the right, it would be shade right.
Yep, positive greater is to the right.
And then negative would be less than, go to the left.
Yep. So this would be an example of a shade left. This would be an example of a shade above. How about if I did this? Where would that be?
That would be 4.
So where would you shade?
It would shade.
Yep. It's an X by itself and it has a less than, and the chart says left. Yep. Okay, does everybody have that chart? We might do that chart again tomorrow too. Tomorrow is really just more practice with today's stuff.
Well, you have class tomorrow?
Thursday.
Yo, we have time for our homework, guys.
So let's finish up these last two.
Oh,
Okay. So first of all, is this a regular case or a special case?
Look at the time.
Oh, that did not register.
What do you think? Regular case or special case?
Special.
Yeah, what makes it special?
Because it only has a
Why?
Yeah, it only has one letter. When you only have one letter, it's special. Okay, this is a Y by itself. Okay, look at our chart.
It's vertical.
When you have a Y by itself, what kind of line direction do you have?
side to side.
So can you tell me just
Horizontal?
using, yeah, so this one, horizontal. Yeah. And what number? Well, we know it's horizontal, but what number is it going to be at?
2.
It's going to be at the number 2, exactly. So it's a horizontal line, and it's at the number 2. Now, should it be dotted or solid?
Solid.
Yep. So it's a solid line at the number 2. What I'll do is I'm going to make that, make it a little thicker so you know it's the line. Make it a different color or something. Okay, so there's our line. Now, do we shade above or below?
above.
Yeah, because it's a greater than or equal to, and that says to shade above. So do you shading? And some people, when they do the shading, like on homework, they just do it like this. This is fine too.
Can we do like an outline?
Just somehow shade it a little bit, whether you just want to put lines or some people color the whole thing. You don't have to color the whole thing, but just do a little bit of
Or
shading.
can we just write shade?
Stop being difficult.
I just color it.
I guess you could write the word shade. Like I said, on the test, it's going to be very simple. You'll just click up here to shade above, click down there, and it will shade everything under it. It'll be automatic.
Shade.
Okay, let's look at the last one. All right, so special case or regular case?
Special.
Yeah, what makes it special?
There's no Y.
There's no Y, it's only an X. Okay, when you have an X only with no Y, what kind of line is it?
Up and down.
Yep, so it's going to be an up and down line. Where is it going to be? An up and down line that goes through what number?
3.
Has to go through the number 3. Yep. And is it going to be solid or dotted?
Dotted.
Okay, so let me make
Yeah. It's like
make my line off to the side. Make it dotted. And where is it supposed to go? Through what number?
3.
3. So 1, 2, 3. So X by itself, vertical, through the number 3. What's the last thing I have to do?
Shade.
Yep.
The left.
Yep. So look at the sign. It's a less than. Less than in the chart says left. And you can have that chart on the test if you want to copy it on your reference sheet. Okay, so shade everything to the left. There you go. And remember, does it really stop right there?
No.
No, it keeps going to the left,
Infinite.
up and down forever. And what would be a point that's somewhere in the red shading?
0, 0.
Yep, 0, 0, that would be a point. So that would be a solution. Somebody give me a point that would not be a solution.
Positive.
10.
Positive 10, what?
9.
9, yeah, that's up here. That's not in the shaded area. That is not a solution. Yep. All right. So any question on that? All right. So I purposely made today a little bit shorter, so that way you have a little time to start the homework.
Thank you for that.
We've got about 20 minutes. It's just worksheet 5.6, part 1. So the homework is worksheet 5.6, part 1.
Can I print them?
So the homework is worksheet 5.6, part 1. You got it? All right. Remember that this is the last week of the term. So we have one more homework assignment after this. And then I'll be doing the grades on probably Thursday or Friday.
Wait, will you be staying after on Thursday even though there's no school?
I'll be after Wednesday.
Wednesday? Okay.
I'll be after Wednesday this week, because there's no school Friday.
So do you think I got 100 on my classwork
Usually,
grade?
but
On your what?
On my classwork grade?
I don't know. We'll have to see.